What is in fact up, all of you? Welcome back. We're going to do some complex number solution-y things, modulus argumenty vibes today. We have a sextic? I don't know, a pair of 6, right? A polynomial pair of 6, z to the 6 plus 8z cubed plus 64, and z can be complex. That's why we're using z and not x. Come on, do keep up. Right, first of all, if f of z is 0, show that z cubed is equal to this. No worries, I gotcha. Because of course, this is a quadratic in z cubed. Right, it very clearly is. That z cubed plus 4 plus 48 is 0, which tells me that z cubed is minus 4 plus or minus square root 48, which is minus 4, I, plus or minus 4 root 3 I. Step 1 accomplished. Step 1 accomplished. Okay. Step 2, let's actually find all the z values. All right. Now, we need to find the cube root of this. That's no fun. No, that's not fun. But what we might want to do, all right, what we might want to do is the following. Now, they suggest that we're going to write z in the form re to the I theta, and I can do that. That's fine. I am a grown mathematician man. Debatable, but still I can do that. But to solve this properly, I want to write this in modulus argument form, which we did earlier. Feel free to check this yourself. It's 8e, this complex number here is 8e to the plus or minus 2 pi over 3i. And in fact, I will remind you that we can always add 2k pi onto that as well. Main fact here. So what we can do is looking at the r's, we can say that r is 2. And looking at the thetas, we can say that 3 theta is plus or minus 2 pi over 3 plus 2k pi. So theta is plus or minus 2 pi over 9 plus 2k pi over 3. So the different values of theta that I want are, we'll get 2 pi over 9, 8 pi over 9, 15 pi over 9. So if I add another 6 to that, has that gone wrong? 2k pi over 3 is 6 pi over 9. 2 plus 6, 14. There we go, much better. Add another 6 onto that. Yeah, that works. And then in the negative realm, because we want pi between minus pi and pi, that will work as well. Oh, that one's too big. That one's too big, isn't it? That one's too big, so we can add 6 pi over 9, and I can subtract 6 pi over 9. There we go. There we go. And then that one I can always add 2 pi over 9 to get 4 pi over 9. Okay, primary solution, secondary solution, or the plus or the minus, and I can just add or subtract the 2k pi over 3 plus 2k pi over 3 minus 2k pi over 3 minus 2k pi over 3 plus 2k pi over 3. So those are my solutions. Okay, all of them have r equals 2, so I'll have re to the 2 pi over 9i, re to the 8 pi over 9i, etc., etc. There's no need to rewrite them for us right now today. Thank you very much, good sir. Now, one thing we're going to go with here is part C, part 1, and then we're going to think about this properly. The sum of the 6 roots. Well, if we look at this polynomial, this is where we're bringing in, again, the roots of polynomials that we know. We know that the sum of the roots in this one equals minus the coefficient of z to the 5. Well, what is the coefficient of z to the 5? It's nothing. So the sum of the roots is 0. Basic roots of polynomials formula. Very nice. Right. Now then, if the sum of the roots is 0, right? z1 plus z2 plus z3 plus z4 plus z5 plus z6 is 0. The important thing to note is the sum of their real parts is 0 and the sum of their imaginary parts is 0. So what this tells me, right, is the sum of the real parts of zi is also equal to 0. Now, what are the real parts? Well, it's cos of this, cos of that, cos. So that's telling me that cos of 2 pi over 9 plus cos of 4 pi over 9 plus cos of 6 pi over 9. I think we should be okay there. Plus cos of minus 2 pi over 9 plus cos of minus 4 pi over 9 plus cos of minus 8 pi even, 8 pi over 9 is equal to 0. Now, how have I written it? Why have I written it like this? A for space, but also, and this comes into something that we see quite often, those are equal. They are the same. Cos of 2 pi over 9 is equal to cos of 2 pi over 9. Those are equal. Those are equal. So that does tell me that cos of 2 pi over 9 plus cos of 4 pi over 9 plus cos of 8 pi over 9 is equal to 0. Now, if we go have a look at what they've written here then, right, so I don't need this anymore. I've had all my thetas. So what can I now say? Well, if I look at the full expression, sorry, that looks a little bit special. Well, that is equal to, because those are equal to 0, so it's equal to 0 plus cos of 6 pi over 9. And cos of 6 pi over 9, that is cos of 2 pi over 3, which is minus a half as required. Done. So we're still looking at, we've got this idea again of I've got 6 roots, cool, but actually when you start looking at them in terms of causes and sines, whilst you've got 6 different values of theta and put them together with as a complex number, there will be different complex numbers, but some of them will have the same real parts, some of them will have the same imaginary parts, and that's something that we are going to leverage time and time again in these sorts of questions over here with the solutions over there. Look at me, woo, spatial awareness. Wicked awesome, amazing. Let's keep doing more of this. If you enjoyed this, please don't forget to like, subscribe, leave a comment and hit the notification bell so that you don't miss the next one of these. I am, have been and will always be Nick, and I will be doing some maths. I will see you soon. Bye.